We're going to be starting in just a minute, just so that anyone coming late doesn't miss anything, because I'm pretty excited by this webinar. We're going to be starting in about 2 minutes. Until then, you can hear me yapping on about about something. But I'm very excited here today that we have a great guest with us. Now we have Baruch Sadogursky with us from TuxCare, who is a real leader in the space of end-of-life dependencies, how to secure that. So it's going to be a great conversation. I just spent 2 minutes practicing the last name. I don't know how I did.
It was great.
Baruch? It was
Yeah,
great?
you
Okay.
nailed it.
There we are.
Yep.
I'm only going to pronounce the last name once. I'm just going to stick with Baruch now. So I got it right one time.
Yeah, no,
But it's
everybody get a pass on trying to pronounce my last name to begin with, so it's just like Baruch is fine.
perfect.
The first name is rare enough, though I don't need to qualify it with the last name.
Yeah. Which Baruch are you talking about?
Yeah.
That's cool. Yeah, my middle name is Clockley, which is quite a challenge for anyone that tries to
Yeah, no, I
pronounce
just
that.
added my Starbucks name as an official middle name, so you can just call me Bruce.
Bruce. Okay. Oh yeah, that's
Yeah.
your Starbucks name.
Yeah, that's the Starbucks name. Makes it easy on everybody. I love that. And yeah, now it's official. Baruch Bruce Sadogursky. Yep.
Yeah, fantastic. I'm just going to. I'm not sure. So just some housekeeping just before we get started. It's going to be about 1 more minute. Then I'm gonna hand it all over. But there is a Q&A tab just down the bottom for you. If you guys have questions throughout the webinar, you can put them in this Q&A section. We have some designated time at the end to go through these. So if you have questions, you don't need to wait till the end. You can put them in right at the front. So as you're thinking about something, go through it, and I will do my best to try and get to all of those questions. But yeah, well, Baruch, I'm always curious, just before we get started here. You are a kind of a technical evangelist, an advocate at TuxCare. How did you get into that role?
So I've been doing developer relations for DevOps and then DevSecOps for the last 15 years by now. Started at in JFrog back when it was like less than 10 people company, and the founders there, they knew me from our previous role, as we all worked in the consultancy company around Java technologies, and they knew that I kind of outspoken extrovert and love to talk to people and know how to explain things. And they're like, hey, we need Secretary of State for JFrog. And up until now, I think that that's the best description of what developer relations is, frankly. Yeah, and then we kind of learned on the job, all of us, what does it mean? What is the right way to kind of be with the developers, help the developers, not being evangelist, but being like a true advocate for the developers in the organization. And yeah, I've been doing it for a long time, with different companies that all have kind of relationship to DevOps, DevSecOps, Java technologies, this kind of stuff. Yeah.
Yeah. Yeah, it's really interesting. How I got into DevRel. There's the story that I tell people, and then there's the true story. So the true
Yep.
story is that I'd moved to Paris. I didn't speak French. I didn't have a job. I kind of was there, and I typed into a job search native English speaker into a tech job search, and then I found developer advocacy. So that's the official story. No one tell anyone that. I tell a different story when I'm doing job interviews and whatnot.
I can imagine. No, it's a good story, and really, yeah, I imagine that in France, not speaking French is a challenge. Is a challenge.
Yeah. Yes. I think it
Yeah.
was. I was there for
People really care if you don't give the proper respect to the language. My sister lives in Paris, and have a lot of stories when we come to visit and what's not. And she always apologizes to the locals for the stupid Americans that don't know the divine language.
Well, I think we could get I think we could get started now. We've talked enough nonsense, so we can get into it. But I wanted to talk to people and explain why I thought this was such an important webinar to do at the moment, at the present time. It shouldn't be any surprise, and I think most people on this webinar will be aware of all of the supply chain attacks that are going on at the moment on MPM. And the advice for this, when we're dealing with these packages that have big vulnerabilities in them, with packages with malware, we know how to deal with a lot of this. We know that we should pin versions of our dependencies. We know that we should deal with CVEs and areas like that. All of that information is there, but there's something that isn't talked about in the supply chain, and that what if we can't fix our CVEs? What if there's no support for it? And all of these areas, and this isn't something that's talked about. The risk of it
And
isn't well known.
the usual advice will be, well, just upgrade. But it's not just upgrade, is it?
Exactly.
Yeah.
No,
Yeah. So
no.
this is what we're gonna talk about today. Yep.
So I'm thrilled that Baruch said that he was going to come on here as part of TuxCare, which is a leading organization with this. So Baruch, I'm actually going to shut up now because I, like all of our guests, want to listen to you. So I'm going to hand it over to you and just remind everyone that there is the Q&A tab down there. So if you have questions along the way, make sure you use that and I'll try and do my best to get to them at the moment. But Baruch, over to you.
Thank you, Mackenzie. So let's start with the statements that you already know for sure. Open source is absolutely everywhere, right? There is studies coming out all of the time, and now you can see that 97% of the code bases contain open source, and 900 components per application. That's a lot, and 70% of scanned code have origin in open source. Numbers up, so absolutely is struggling. The number of just like files in average application tripled in the last 4 years, and this is really mind blowing. So this is a foundation of every application, but this foundation kind of shows cracks. Amazing 86% of the code bases include vulnerable open source components, and 81% have high or critical vulnerabilities. And even more striking, 91% of all code bases include outdated packages, and 90% were more than 10 versions behind. There's a huge gap between what's used and what's current, and it's not just a security issue, it's an organizational one. Organizations are struggled to stay on top of updates, especially in complex environments. And I will give you an example. This chart shows 6 different components inside single standard application, right? And we can imagine an application or a company that runs online banking platform where customers can log in, check balances, transfer funds, receive notifications, and those are all the packages that or the components that they are used, right? So Apache Kafka for messaging, and then Node.js for front end, Spring Boot for backend transactions and what's not, OpenJDK as the Java runtime, PostgreSQL as the database for the data, and then Ubuntu as an operating system. And you can see here how each of those components has its own community support timeline. So the software development team needs to manage 6 separate end-of-life dates, making sure no piece falls behind and no piece falls out of support. And if only one of them does, the entire app becomes vulnerable. And in bigger environments, this becomes a real headache. Upgrades need to be planned in advance to avoid breaking anything, and engineers often have to stop working on new features just to deal with maintenance. You know all the things, right? And when the component reaches end of life, there is no more security patches, and then you have a huge compliance risk that in the modern frameworks puts even more pressure on the development teams. FedRAMP, PCI DSS, HIPAA, ISO 27001, they require all those high and critical risk vulnerabilities to be resolved within days or weeks at most, but definitely not months. And the problem is with the component is already end of life and there is no vendor patching coming. So engineers are forced to rush to upgrades to emerging versions, which obviously create tons of work. So we talked about how teams often end up rushing upgrades, but even when they have time to plan, upgrade is almost never simple. It usually starts with going into the code and upgrading anything that no longer works with the new version, and then maybe a feature has been renamed, removed, or a behavior change just enough to cause problems. But fixes are only the beginning. The moment one piece gets upgraded, team often have to check everything else around it. Libraries, services, other apps, just to make sure nothing else breaks. And that's where the real chain reaction starts. Then there are tooling, build system, packaging, deployment scripts. All this needs to be adjusted to support the new version. And finally, there is testing, lots of testing, regression, integration, performance, all to make sure that the upgrade didn't break anything. So when the customers want to avoid the unplanned upgrade, it's because they know how much it actually involves. And when the teams are forced to rush through the upgrade, the impact doesn't end once the new version is alive. It usually creates a ripple effect. First, there is increased support load. Bugs and urgent fixes start popping up, pulling developers and support teams away from what they should do. And then there are workflow disruptions. And instability slows everything down, from engineering to operation, and throw off all the schedules. It almost always leads to technical debt. Team cut corners to meet the deadline, and those shortcuts often stuck around so longer than they should, creating technical debt and future maintenance. And then there are unplanned costs. Teams may need to spend extra servers, testing environments, pay for overtime, all just to keep things running. There is absolutely no new features, it's just an upgrade. And when we're talking about cost, we can talk about numbers. We can talk about research by the front-end company that shows that an upgrade from outdated AngularJS to modern Angular takes 9 to 12 months. We can talk about Stripe research about technical depth and see that per average developer spend 13.5 hours a week addressing technical depth. And we can talk about real money figured out by Boston Consulting Group, ROI drop from 10x to 4 or 5x because of 6 month sleep in a schedule because of technical depths and upgrades. And this brings us to a solution. And the solution is to give organizations complete control over open source lifecycle risk. And this is what we did when we launched the dramatically expanded now endless life support portfolio. Now it's built to cover open source packages at any version across any layer of the customer stack. 3 key components: ELS for operating systems, ELS for runtimes and libraries, and ELS for applications. Together, those cover the entire stack from open source all the way to production applications customers rely on. And that means no more scrambling when a component hits end of life, no more last-minute upgrade projects, and no more compliance gaps. You can control your upgrades. So what exactly does ELS for open source deliver? It's not just about stretching support for a little longer. It's a complete production-grade service built to meet enterprise expectations. We deliver SLA-backed security packages for software vulnerabilities quickly and for as long as the customer needs. We cover the entire dependency tree out of the box, including all the transitive deeply nested dependencies. Every patch is extensively tested to make sure it works with customer existing code, so they don't have to worry about breaking changes. And our upgrades plug directly into customer existing workflows and CI/CD pipelines with the best DevOps practices, so no need to change how they deploy. All pages are delivered through secure, tamper-proof packages hosted on trusted TuxCare repositories. And finally, our team is available 24/7 to help with CVE triage, patch requests, and any issues that can come up along the way. This all ends up to a fully managed, highly reliable service that allows customers to stay secure without compromising stability or compliance. And for security conscious organizations, especially regulated industries, who require verifiable assurance that the software that's finally deployed can be trusted. And we have components to help with that. Software bill of materials that is released with every ELS component chip, and give you a complete audit-ready inventory, and then exploitability exchange, so you can know which CVEs has already been remediated to release and which are not applicable and not exploitable, so you can cut false positives. And then SLSA level 3 that is coming up in Q4, just around the corner. The package will be signed to verifiable standards according to the new standard. So one of the biggest strengths of TuxCare end-of-life support offering is that it's not limited to a fixed list or a catalog. Out of the box, we support a wide range of open source components across the entire stack. But the interesting part is that we are really ready to take on whatever the customer needs. So if something is not on the list, you reach out to us, we evaluate the request, come back with clear timeline. In most cases, we're talking about anything between 2 weeks to a month to cover this new technology, and you are protected again. So this flexibility means that you never have to feel boxed in. It's open source. If it's open source and critical for your environment, we are there to help you. And here is what's happening behind the scenes. It starts with 24/7 automated CV tracking. We continuously monitor the National Vulnerability Database, vendor advisories, GitHub Security Advisory, other sources of vulnerabilities, as soon as they are discovered, we are on it, and we backport the relevant fix from the upstream using AI-driven automation that I'm going to show you soon, and with every patch validated by our engineers before release. And then when your system check for updates, either through package managers, build tools, or orchestration platforms, it will discover that there is a fix and will pull in the tested TuxCare patch, which is just like another upgrade. So this is the automation that I told you that I'm going to show you a little bit. So we're talking about 3 different pipelines. The first pipeline is the project onboarding, and this happens only once per project. The idea is that we try to understand how to build this project, because we will have to rebuild it with the patches included. Some package managers, build tools, and technology stacks are easier than others. Java, my kind of alma mater, if you build a project in Maven, we know exactly what to do. All the projects built in Maven are the same. If you use other package managers or you use other technologies, it might be harder. AI helps a lot, because AI learned on tons of open source projects in the wild, and it can steer us into the right direction to show us how to build a particular project. And sometimes there are exceptions that require human escalation. We will dig into the project to understand how to build it correctly. Now, what happens every time when vulnerability is discovered? First of all, the automated vulnerability discovery. We scan the sources that I mentioned, NVD, GitHub Security Advisory, and many others, and then we discover that there is a vulnerability. Usually, by the time vulnerability is disclosed, there is also a solution made for it. And the patch that patches this vulnerability will usually be clearly stated. We need to find this patch, and then we need to assess if the version that we are looking is vulnerable for this particular vulnerability. Maybe the vulnerability, the vulnerable code was introduced later, and then the code that we are looking at, that we're supposed to patch, is not even vulnerable, and then we don't need to do anything. If it is vulnerable, is vulnerability that was discovered also affects the version that we have, then the magic happens. And this box right here, the automated page backporting, this is our, should I say, proprietary magic. We know how to very quickly and very efficiently take the code from the patch of the latest version and successfully apply it to a version that might be a year, 2 years, 3 years old without breaking the code. It's a combination between AI and algorithmic solutions. There are different strategies that we try to see what actually works. And we actually manage to achieve a very, very high percentage of automation in backporting the patch. And I'm bragging about it not just because it's very, very cool technologically, but because it's very important for you. This is how fast can we release the patch so you will be protected both for your security posture and for your compliance posture. Once we manage to backport the patch, we do the test validation using the existing tests the project has, and using a manual code review, very important and mandatory part. All the automation is nice, but eventually we need to take a look at it. And then we're ready for the release, and the release is not necessarily tied for the remediation, because maybe sometimes we want to bundle a couple of patches together or release it on a certain cadence or a date that we prefer to release it instead of being released immediately. And the release pipeline is scheduling the release, and from there everything is automated. And we are talking about version upgrade, dependency update, build, test, and run and sign, and publishing the artifact, the SBOM, and the VEX artifacts that come with the patched version. And from there, your build tool can be your build scripts or your project descriptors should be updated to consume the newest version. You can do it automatically with version ranges, as it's more common in some languages and stacks. You can do it manually if you want to control when you upgrade, and you might discover that there is a new version by new SBOM being published, and then manually upgrade in staged environments before you do it in production. That's up to you on how do you prefer to use it. So this is how the magic happens, and this kind of let's talk about the three different components. So ELS for operating systems, that was our main offering since the very beginning, and this is where many of our customers first experience the value we deliver. We have minimized the risk on ongoing security vulnerabilities. For high and critical severity vulnerabilities, we provide a very robust SLA of 14 days, and that's for compliance and for security. We secure core packages, the essential server components of Linux to make it stable and safe. And you can always see what's been fixed through detailed errata, as it is common in the Linux community, CVEs IDs, affected packages, and we support patch verification using OpenScalp and other OVAL compatible tools, again, as it is common in the community. No migration needed. You just connect to TuxCare repository, and then the upgrades will come from that repository, and you will get the patches. The second layer is the runtimes and libraries, and this is where we bring value for software teams. Modern applications require complex webs of open source libraries and runtimes, and our coverage spans through all the ecosystems: Java, JavaScript, Python, PHP, Ruby, and more. And also, as you remember, you can request your own. End of life runtimes and libraries create ripple effects that impact every team, and ELS helps eliminate exposure to vulnerabilities in unsupported components, make it easy to maintain compliance without rushing from upgrades. Development teams avoid overhead of rewriting code, of chasing down breakdown changes, and product teams can stay focused on shipping features instead of pausing roadmaps with forced migrations. And obviously for IT leaders, ELS reduces the unplanned cost, avoiding drills and infrastructure strain and all this kind of stuff. So ELS for runtimes and libraries help each team stay focused on their priorities without breaking side tracks. Connecting ELS also is quick and straightforward, and the setup steps are tailored for each and every ecosystem. But essentially, you need to get the credentials to access the corresponding repository, update configuration of your dependency manager for the right versions of the patched artifacts, and that's it. Then you build, and you are protected against emerging vulnerabilities as long as you need it as you upgrade the versions. ELS for open source applications. That's the third kind of key layer in ELS portfolio. And this service is about keeping legacy open source applications secure without breaking everything that connects to them. And we have drop-in patches that preserve existing integrations, so customers don't need to have to rewrite plugins or rebuild interfaces or rework automation just to stay protected. And custom configurations are safe too, whether it's performance tuning, workflow-specific settings, our upgrades won't interfere. And since the patches are delivered in place and without reboots, you can apply them without disrupting users or causing downtime. And the setup is, again, as simple as for ELS for open source. Customers just to run the script, and then they're giving, they have access and they're protected. And generally, all the ELS solutions come with robust SLA guarantees. For example, high and critical vulnerabilities are patched as fast as 14 days. This is absolutely critical. So what makes TuxCare the best choice for supporting end-of-life open source software? First of all, we provide long-term security across the entire open source stack, supporting a wide and continuously expanding set of open source projects, libraries, and runtimes, all from single trusted partner. Second, we utilize advanced automation across CVE discovery, backporting, building, and release, as I showed you earlier, to accelerate delivery and ensure the highest possible quality of security patches. Third, we go beyond surface level scanning and uncover and fix vulnerabilities hidden deep in your dependency trees, securing entire software supply chain and precision at scale. This is very rare and very critical. And finally, our automation pipelines ensure rapid rapid solutions, so you will have the CLA covered as well. This is all nice, but can we prove it with numbers? Yes, we can. You can see here the number of customers and packages supported, packages delivered, vulnerability fixed, Linux kernels in particular patched, and Linux distributed version supported. This slide speaks by itself. This massive number of what we can provide, all based on this key automation that I showed you earlier. So this is not surprising, but I think also kind of impressive. And this is why you can trust us for your end-of-life support. Mackenzie?
Yeah. So
Back to you.
Back to me. One of the things that's really cool that I'm happy to share too is at Aikido we really consider this to be a very important part of securing your supply chain, because it's and as Baruch was kind of saying too, it's very common to have these issues with end of life support, particularly in larger organizations, areas like that. So in the Aikido platform, we are now offering through TuxCare, through a partnership with TuxCare, some of the same end of life support for dependencies. So you can actually upgrade your dependencies to a TuxCare supported version to solve some of the critical issues that you have inside them. So that's something that we're really quite excited about, and very proud to be partnering with who we believe is the leader in this space. And I think after Baruch's presentation, it's pretty obvious why.
Yeah, thank you, Mackenzie. And yeah, we are also very excited because this is one of the most useful ways for the users and the customers to kind of see what their options are, right? Because other scanners and tools, they will just show you, well, upgrade to version 2. I mean, how hard can it be? Yeah, you're kind of stuck, and you probably going to ruin your entire application, but we don't have any better advice. And showing that there is another way, and showing right there in the interface very clearly is absolutely game changer. And I think that this is one of the most useful integrations that an end of life support provider can have. So thank you for having us right there in Aikido interface.
Yeah, definitely. And what I might do too is just to kind of show that it is actually real. This is what it kind of looks like in the product if you're using Aikido or not. And we have here these two. This is in our kind of auto fix feature, just to give you a very quick kind of view of what it looks like. And what you'll notice is that in our kind of mitigation to upgrade, you have here this option of upgrading to a TuxCare supported package. So you see there that 1.2.17 and 1.2.17.tuxcare. That allows us to get rid of this critical vulnerability, which you may be familiar with if you've been in security for a little bit of time. And so you don't need to break your application to try and solve that too. And you can see that there's multiple different areas that we have in it. So
Yeah, so basically our goal is, so next to every major, like this red badge that hey means headache, you will have also an option, well, no headache or headache postponed.
yeah, headache postponed. I love it. But yeah, once that headache is postponed, it's, yeah, like if it works and it's secure, like I think it worked at
Well,
that point.
yeah, no, it's still very, very important to upgrade because there are different reasons for upgrade, right? There is better performance, there is better probably
Right.
developer experience and what's not, but the ability to upgrade on your own terms and not because the regulators breathe on your neck or because you cannot sleep at night because you know that the attackers and the hackers out there will actually look for your particular outbound component is a huge win.
Yeah, and I think like we just looked at the log4j example. I think if we actually go back to like log4j, you know, you have this giant critical vulnerability that not only you are aware of, but all of the attackers are, and solving that can take time.
Exactly.
And dealing with that. And when you're dealing in a fast-paced scenario, to have an option that at least gets rid of that, I'm about to kind of have a total system compromise, then you can understand why that's so valuable. Um,
Log4j is one of my favorite examples in the security world because how ridiculous it is. The story about it is that this vulnerability is actually a feature that was there from version 1. The ability to load in runtime Java code that will allow you to expand your ability to log to other sources was one of the features that Log4j was very proud of. And the way that it became a vulnerability is 100% in our heads. Technically, nothing changed. It's just one day, someone woke up, looked at this feature, and said, you know what? If I can load arbitrary code, I can load arbitrary code. But there is nothing there that was exploited. It was
mm.
a public feature, well documented. We knew exactly how to use it from day one of Log4j. This is amazing.
Oh, yeah, that one really keeps me up at night too, just thinking about it. Along with all these like big NPM supply chain attacks at the moment, is that, you know, it makes headline when someone puts malware in it, but sometimes you don't even need to put malware in it. Sometimes it's a feature. So
Exactly. That was there forever. All it takes is for someone to think about it maliciously and decide
yeah.
that, hey, I'm going to exploit it. And then the entire world is on fire. How fun is
We
that?
Yeah, well, not December 2021 was not fun. I'll say
Yep,
that.
yep,
Ruined a
yep.
few Christmases, I suspect.
That's for
Um,
sure.
we have some questions in here that I kind of want to get to. Now, a reminder, if you have some questions, there is the Q&A tab there. So, um, one of the questions here is like, how do you kind of identify when a dependency has gone end of life? So I guess what they well, that question is like, how do you know if you, I guess, how do you know if you have end of life dependencies that you can't upgrade for? Like what?
So the question is, when do you decide to upgrade, right? So and why? You have a version, and this version, for all intents and purposes, is good for you. You might know about a new version from different sources. It might be your security advisory. Hey, there is a vulnerability you need to upgrade. It might be some feature that it only exists in a new version, and then you need to upgrade. Usually, we will upgrade when there is a need. And the combination of there is a need, there is security vulnerability, and there is no patch, and no patch is coming, this is the sign of end of life, right? So usually open source projects will publish their timeline of when do they plan to stop supporting. That's true for every ecosystem. And the graph that I showed previously on one of the slides that showed the planned end of life let you plan. But for random packages, you will discover that it's end of life when you need to upgrade for some reason and you can't because there is no new version.
Mm. Yeah, yeah, a nasty a nasty surprise, especially if you're
Yeah.
trying to deal with something in a hurry. So I this kind of leads into the next question there, and the actual question is, do attackers actively scan for end of life components in the wild? But I think what more of that is you mentioned it that these packages actually announce when they're going to go into end of life usually. So I
Yes.
guess I'd frame the question as kind of attackers aware of that? Do they actively try and find these packages and exploit them? Like, is that an attack path for them?
And the answer is absolutely yes, for sure. This is the low hanging fruit. This is the longest, the lower hanging fruit there is. Obviously,
Mm,
if an attacker knows that there is a vulnerability in a version that no patch for it exists, this is the natural kind of the first line of attack. This is where you go, this is where you start. So yes, definitely. And that makes it even more painful. Not only you now need to upgrade to to a major version that you cannot. Not only you have now compliance issues that you won't be covered in like whatever weeks PCI DSS requires you to upgrade, you are actually actively being targeted by hackers who know that you are not protected and cannot be unless obviously you take something like TuxCare.
yeah. And the last question that we have here is, and I think maybe we've kind of already answered this in the other ones, but like, how common is it for orgs to be running end of life dependencies? So you kind of mentioned that you're probably going to discover this when you go to upgrades for some reason. But is there scenarios where you often have end of life components and you're just completely unaware that actually it's unsupported?
So 91% of all the code bases contain outdated open source components. And 90% of all the code bases contain components that are 10 versions behind the most current version.
Mm,
So yes, not only it's possible, most of the project, like 90%, 9 out of 10 projects have outdated open source components. Now, it's a slightly different question of how many of them aware of it and do nothing about it, but I would assume that the majority of those numbers come from projects that are not aware that they are running end of life, the components that are already outdated and end of life.
yeah, and that makes total sense from there. And it's like it's a scary thought that there's so much for this, but this is kind of like the state of the
It's
supply
terrifying.
chain.
90% is definitely not a number that I would guess. I would
Yeah,
say
no,
pessimistically 50, but I would never think about 90.
yeah, no, I think, yeah, that's I mean, absolutely. And as you say, it's that like I think when we talk about this, you know, the solution that we provide seems so easy. Just upgrade to the latest version. Just do this, do that. What it all just seems such like a simple solution, but then, yeah, it's is most definitely
Yeah, no,
it's
and
most
to give
definitely
you
not.
credit, at least you mark it with a right with the red badge. Right. So you kind of imply that, hey, there is something serious going on. But there are tools that will tell you, yeah, just upgrade to the next major version. How hard can it be? Which is
Yeah.
obviously a lie.
Yeah, for sure, for sure. Well, Rook, we've come to the end of the time here, but I really wanted to thank you for that presentation. As I said at the start, one of the reasons why we really wanted to discuss this is because supply chain is a hot topic, and this is a part of that that's not often talked about. It doesn't, often make it through, but is a huge risk. So, thank you for sharing the knowledge with us. Thanks for TuxCare for partnering with Aikido. Also, thanks to Aikido for partnering with TuxCare because I'm pretty excited and happy about that too. So.
Absolutely, absolutely. This is great, and I'm very excited about it as well. And as I mentioned, this is such a huge improvement in developer experience when you can just not be terrified for a second about the next major upgrade, and you have the luxury to plan it, and you know about it just by looking at the scanner and know that there is a solution that won't cost you an arm and a limb to implement.
Yeah, absolutely. Well, thank you again, Baruch. It's been a pleasure, and I'm sure we'll have you doing more things with us, hopefully, to talk about this issue in the future. So, thank you everyone for tuning in and attending, and make sure you keep following announcements on Aikido of the next webinars. We'll be trying to do more webinars like this. So, thanks everyone. Thanks, Baruch, and we'll see you all on the next one.
Thank you, Mackenzie. Bye bye.